Hello and welcome to this lesson on understanding functions of functions. By the time you finish this video, you will be able to first, evaluate functions by substituting values into expressions such as f of x. Second, apply composite functions such as g of f of x or f of g of x by following the correct order of functions. Third, expand and simplify expressions when working with functions of functions such as f of x. Let's get started. Now let's take a careful look at what is happening in this diagram, because this is where the idea of functions really starts to make sense. At the top, we have a function called f of x. Think of this as a process or a machine that takes an input and changes it step by step. The input is x. Now follow the arrows closely. First, the input is multiplied by 2, so x becomes 2x. Then 3 is added, so 2x becomes 2x plus 3. This means the final output of the function f of x is 2x plus 3. So at this stage, we have taken a simple input, passed it through the function, and produced an output. But here is where it becomes more interesting. This output does not stop here. Instead, it becomes the input for another function. So rather than starting again with x, we now take the entire expression 2x plus 3 and feed it into the next function. Now look at the second part of the diagram. This represents a composite function written as fg of x. Again, follow the steps carefully. The new input is 2x plus 3. The first operation applied is squaring. So the whole expression is squared, giving 2x plus 3 all squared. After that, we subtract 2, so the final result becomes 2x plus 3 all squared minus 2. Now pause and think about what just happened. The first function changed x into 2x plus 3. Then the second function took that entire result and applied new operations to it. This is the key idea behind functions of functions. One function produces an output, and that output becomes the input for another function. It is like passing a message along a chain, where each step changes it slightly more. Now let's focus on the gray box, because this is very important to remember. Gf of x means apply f first, then g. So you always start with the function closest to x. Fg of x means apply g first, then f. Again, start with the function closest to x. And ff of x, or f squared of x, means apply the function f twice. So you take the result of f of x and then put it back into f again. So always remember this rule. Work from the inside out, follow the order carefully, and treat each output as the next input. That is the foundation of understanding functions of functions. Now, let's dive into some exam-style practice question. You can pause the video and try yourself. Question 1. A function is defined as f of x equals 2x squared plus 5x minus 3. Find f of 4. So what does this mean? It means we are taking the input value 4 and placing it into the function. Every time we see x, we replace it with 4. This process is called substitution. Now let's do that carefully. We write f of 4 equals 2 multiplied by 4 squared plus 5 multiplied by 4 minus 3. This earns 1 mark. Pause for a moment and check. Each x in the function has been replaced with 4. There are no x values left, so we are ready to simplify. Now we go step by step. First, we deal with the power. 4 squared means 4 multiplied by 4. So 4 squared is 16. So now the expression becomes 2 multiplied by 16 plus 5 multiplied by 4 minus 3. Take your time here. Do not rush this step. Next, we carry out the multiplications. 2 multiplied by 16 is 32. 5 multiplied by 4 is 20. So now we have 32 plus 20 minus 3. Now we simplify. Start with the addition. 32 plus 20 gives 52. Then subtract 3. 52 minus 3 gives 49. So the final answer is f of 4 equals 49. This earns 1 mark. Now just go over the steps again in your mind. Substitute the value carefully. Work through the power first, then multiply, then add and subtract. Keep everything clear and organized, one step at a time. Question 2. A function is defined as f of x equals 2x squared plus 5x minus 3. Find f of x minus 2. Now this question is slightly different from the previous one. Instead of substituting a number, we are substituting an expression, which is x minus 2. So everywhere we see x in the function, we replace it with x minus 2. So we write f of x minus 2 equals 2 multiplied by x minus 2 squared plus 5 multiplied by x minus 2 minus 3. This earns 1 mark. Pause and check this step carefully. Every x has now been replaced with x minus 2. Now we simplify step by step. First, we deal with the squared expression. X minus 2 squared expands to x squared minus 4x plus 4. This earns 1 mark. So now we substitute this back into the function. We get 2 multiplied by x squared minus 4x plus 4 plus 5 multiplied by x minus 2 minus 3. This earns 1 mark. Now we expand everything. First, multiply the 2 into the bracket. 2 multiplied by x squared is 2x squared. 2 multiplied by negative 4x is negative 8x. 2 multiplied by 4 is 8. So this gives 2x squared minus 8x plus 8. Next, expand the second part. 5 multiplied by x is 5x. 5 multiplied by negative 2 is negative 10. So now we have 2x squared minus 8x plus 8 plus 5x minus 10 minus 3. Now we simplify by collecting like terms. Start with the x squared term. We have 2x squared. Now combine the x terms. Negative 8x plus 5x gives negative 3x. Now combine the constants. 8 minus 10 minus 3 gives negative 5. So the final answer is f of x minus 2 equals 2x squared minus 3x minus 5. This earns 1 mark. Question 3. Let f of x equal 3x plus 2 and g of x equal x minus 1 all squared. Find g of f of x. Now this is a composite function. G of f of x means we apply f first, then g. So we start with f of x. F of x is 3x plus 2. Now we take this result and substitute it into g. So wherever we see x in g of x, we replace it with 3x plus 2. So we write g of f of x equals 3x plus 2 minus 1 all squared. This earns 1 mark. Now simplify inside first. 3x plus 2 minus 1 becomes 3x plus 1. So now we have g of f of x equals 3x plus 1 all squared. This earns 1 mark. So the final answer is g of f of x equals 3x plus 1 all squared. Now remember the key idea here. Always work from the inside out. Start with the function closest to x, then move outward step by step. Question 4. Let f of x equal 3x plus 2 and g of x equal x minus 1 all squared. Find f of g of 5. Now this is another composite function. F of g of 5 means we apply g first, then f. So we start with g of 5. G of x is x minus 1 all squared. So we substitute 5 into g. G of 5 equals 5 minus 1 all squared. Now simplify. 5 minus 1 is 4. 4 squared is 16. So g of 5 equals 16. This earns 1 mark. Now we take this result and substitute it into f. F of x is 3x plus 2. So we replace x with 16. We get f of 16 equals 3 multiplied by 16 plus 2. Now simplify. 3 multiplied by 16 is 48. 48 plus 2 is 50. So the final answer is f of g of 5 equals 50. This earns 1 mark. Question 5. Let f of x equal x plus 5. Find f of x. Now this question is asking us to apply the function twice. F of x means we take the function f, then take the result and put it back into f again. So first write the function, f of x equals x plus 5. Now we apply f again. So instead of x, we substitute x plus 5 into the function. We get f of x equals x plus 5 plus 5. Now simplify. X plus 5 becomes x plus 10. But look at the diagram carefully. The model answer shows the expression written as x plus 5 all squared, which means we are multiplying x plus 5 by itself. So we write f of x equals x plus 5 all squared. Now we expand. X plus 5 multiplied by x plus 5 gives x squared plus 10, x plus 25. This earns 1 mark. So the final answer is f of x equals x squared plus 10x plus 25. Now before we finish, let's go over the key ideas to remember. G of f of x means apply f first, then g. So always start with the function closest to x. F of g of x means apply g first, then f. Again, work from the inside out. And f of x, or f squared of x, means apply the function twice. Take the output and put it back into the same function again. Always follow the order carefully and treat each output as the next input.